Example. Solve Laplace of x times sine 3x. Again here, the given function f of x is the product of two elementary functions. First elementary function which is x, and third elementary function which is sine 3x. Let me find the Laplace. Solution. I'm gonna take sine 3x first, which is the third elementary function. Laplace of sine 3x equals to 3 over a square plus 3 square. It equals to 3 over a square plus 9. So Laplace of sine 3x equals to 3 over a square plus 9, which is my third elementary condition. Now I'm gonna find the Laplace of x times sine 3x. Where Laplace of x times sine 3x equals to minus 1 times d over dx of 3 over a square plus 9. Again I applied this formula here, where my x to the n is x. Function f of x is sine 3x. And Laplace of sine 3x, which is f of s, is 3 over a square plus 9. I just derived 3 over a square plus 9. The value of n is 1 here. So let me repeat it again. If you have the function f of x, which is the product of two elementary functions, one is first elementary function and the other is third elementary function, which is sine 3x, you have to apply this formula here. And also, if you have the product of first elementary function and fourth elementary function, derivative of 3 over a square plus 9 with respect to s equals to a square plus 9 times 0 minus 3 times 2s or a square plus 9 to the 2. Again I applied this formula here, d over dx of u over v, which equals to v du over dx minus u dv over dx over v square. Just apply this rule here. Simplify the equation further, which equals to 6s or a square plus 9 to the 2. That's how Laplace of x times sine 3x equals to 6s or a square plus 9 to the 2. Example. Solve Laplace of e to the 2x times cos 5x. You see here the given function f of x is the product of two elementary functions. One is exponential function, which is e to the 2x, and the other is cos 5x, which is a trigonometric function. Let me find the Laplace here. Solution. Since f of x is the product of two elementary functions, therefore I'm gonna find them individually first. Let me take first cos 5x, which is the trigonometric function, and I also call it fourth elementary function, which is fourth elementary condition. Laplace of cos 5x equals to s over a square plus 5 to the 2. I apply the fourth elementary condition here, which is cos ax equals to s over a square plus a square, where my constant a is 5 here. It equals to s over a square plus 25. So Laplace of cos 5x equals to s over a square plus 25. Now I'm going to take the exponential function e to the 2x. We have the Laplace of e to the 2x equals to 1 over s minus 2. I apply the second elementary condition here, where my constant a is 2. So Laplace of e to the 2x equals to 1 over s minus 2. Now I'm going to take s minus 2 and we'll put for a square, as well as for s at the numerator. Just replace a square and s by s minus 2 in the above function, which equals to s minus 2 or s minus 2 to the 2 plus 25. This is my final answer for the given function. Example. Evaluate Laplace of 1 over 4x plus x squared plus 1 over 2 sine 5x plus cos h 2x. Again, when you look here, my given function f of x is the combination of many subfunctions, algebraic functions, trigonometric functions. So let me find the Laplace. Solution. I'm going to find the Laplace of all the subfunctions individually. Let me first take 1 over 4 times x. Laplace of 1 over 4x equals to 1 over 4 times 1 factorial over s to the 1 plus 1. I apply the first elementary condition here, which is Laplace of t to the n equals to n factorial over s to the n plus 1. The value of n is 1 here. The power of x is 1 here, x to the 1. which equals to 1 over 4 times 1 over a square. So the Laplace of 1 over 4x equals to 1 over 4 times 1 over a square. Just put it here. Now I'm gonna take x to the 2, which is also algebraic function. Laplace of x to the 2 equals to 2 factorial over s to the 2 plus 1. Again, I applied the first elementary condition here where the value of n is 2 here. So it equals to 2 over s cubed. That's how the Laplace of x square equals to 2 over s cubed. Plus, just put it here, 2 over s cubed. Now I'm gonna take the third term, which is 1 over 2 times sine phi x. It's a trigonometric function. Laplace of 1 over 2 times sine phi x equals to 1 over 2 times phi over a square minus 5. I applied the third elementary condition here, where condition says that the Laplace of sine ax equals to a over a square minus a. Constant a is 5 here. So the Laplace of 1 over 2 times sine phi x equals to 1 over 2 times phi over a square minus 5. Plus, just put it here. Take the final term, which is cos h2x. It is also a trigonometric function. Laplace of cos h2x equals to s over a square plus 2 square. If you remember, it is under the sixth elementary condition, which is Laplace of cos hax equals to s over a square plus a square. My constant a is 2 here. It equals to s over a square plus 4. So plus 1 over 2 into 5 over a square minus 5. Then take this one, cos h2x. Laplace of cos h2x equals to s over a square plus 2 square. It is according to this formula. Laplace of cos hax equals to s over a square plus a square, where my a is 2. 2 square equals to 4, so I will have s over a square plus 4. Put here plus s over a square plus 4. So this implies that Laplace of 1 over 4x plus x square plus 1 over 2 sine phi x plus cos h2x. 1 over 4s square plus 2 over s cube plus 5 over 2s square minus 10 plus s over a square plus 4. Well, this is the final answer of the given expression. Example. Evaluate the Laplace of e to the minus 2x times cos phi x. Look to the function f of x, which is the product of 3 elementary functions: exponential function, algebraic function, and trigonometric function. So let me find the Laplace of the product of 3 elementary functions. Solution. First function times second function times third function. Let me do the Laplace process individually for all the 3 subfunctions. First, I'm gonna take cos phi x. Laplace of cos phi x equals to s over a square plus phi square. I apply the fourth elementary condition here, where my constant a is 5, which equals to s over a square plus 25. Now I'm gonna take the Laplace of x times cos phi x. I ignore the exponential function e to the minus 2x. I'm gonna find the combined Laplace of x times cos phi x. You must know how to find the Laplace of x times cos phi x because we have already done. Equals to minus 1 times d over ds of s over a square plus 25. I applied this formula here, which is Laplace of x times cos ax equals to minus 1 to the n times d over s to the n of f of s. This is my left hand side, which is x cos phi x, and my f of s is s over a square plus 25, which is the Laplace of cos phi x, which I have already derived. So the derivative of s over a square plus 25 with respect to s equals to s square plus 25 times 1 minus s times 2s over a square plus 25 to the whole square. I applied this formula here, d over dx of u over v, which equals to v du over dx minus u dv over dx over v square. Just apply this formula. Simplify the equation, which equals to a square minus 25 over a square plus 25 to the whole square. Just put it here. So the Laplace of x times cos phi x equals to a square minus 25 over a square plus 25 to the whole square. Now pick the exponential function e to the minus 2x. Laplace of e to the minus 2x equals to 1 over s minus times minus 2. Apply the second elementary condition here, which is Laplace of e to the ax equals to 1 over s minus a. My constant a is minus 2 here. It equals to 1 over s plus 2 because minus times minus is plus. So this is the final value for e to the minus 2x. Now pick s plus 2 and substitute it for a square at both numerator and denominator of the above equation. When you do substitution, you will get the final value s plus 2 to the whole square minus 25, or s plus 2 to the whole square plus 25 to the whole square. What I did here, I substitute s plus 2 for a square at both places, and I got this final value. This is my final value for the given function, which is the product of three subfunctions. Example: evaluate Laplace of 2 plus x squared plus 2e to the 2x plus 15 sine 3x. When you look to the given function f of x, it is the addition of many subfunctions. First elementary function, second elementary function, and third elementary function. Let me find the Laplace of the given equation. Solution. I'm going to find the Laplace of the subfunctions one by one. Let me take first constant 2. I can find constant 2 from the formula of the Laplace, which is Laplace of f of x equals to integral of e to the minus sx times f of x dx. I just substitute the value of f of x2 here. Found the integration, which equals to minus e to the minus x s over s. Put the limit 0 and a and take 2 over s out of the equation. Limit a is actually infinity because when you look to the above equation, a approaches to infinity. So a means infinity. As I explained in the previous lecture, that the product of any things with infinity becomes 0. Therefore this term will be 0. Even if the power of the exponential function is in infinity, it is also 0. Here I have the power in infinity because a is infinity. E to the 0 is 1. Therefore I have Laplace of 2 equals to 2 over s. This is my final value for the Laplace of 2. Just put it here. 2 over s plus. Now I will take x squared, which is the first elementary condition, where Laplace of x squared equals to 2 factorial over s to the 2 plus 1. I apply the first elementary condition here, which is Laplace of t to the n equals to n factorial over s to the n plus 1. Whether you take t to the n or x to the n, this is one thing. The value of n is 2 here, which equals to 2 over s cubed. So the Laplace of x squared is 2 over s cubed. Just put it here, 2 over s cubed. Now I'm going to take the exponential function 2 times e to the 3x. Laplace of 2 times e to the 3x equals to 2 times 1 over s minus 3. I applied the second elementary condition here, which is Laplace of e to the ax equals to 1 over s minus a. My constant a is 3 here. So the value of 2 times e to the 3x is 2 times 1 over s minus 3. Just put it here plus 2 times 1 over s minus 3. Now I'm going to take the trigonometric function, which is 15 times sine 3x. Laplace of 15 times sine 3x equals to 15 times 3 over a squared plus 3 squared. I apply the third elementary condition, which is Laplace of sine ax equals to a over s squared plus a squared, where my constant a is 3, which equals to 15 times 3 over a squared plus 9, plus, just put this value for 15 times sine 3x here. Just put it here. This is the final expression for the above function. Example. Solve inverse Laplace of 4 factorial over s plus 3 to the 5. Again, if you look to the given equation, my function f of x is the combination of two subfunctions. Let me find the inverse Laplace here. Solution. One function is 1 over s plus 3, and the other function is 4 factorial over s to the 5. Let me take out 1 over s plus 3 here, which is Laplace inverse of 1 over s plus 3. I left with 4 factorial over s to the 5, which is my another function 4 factorial over s to the 5. I just separated the two subfunctions. Let me write inverse Laplace of 1 over s plus 3 times inverse Laplace of 4 factorial over s to the 5. Inverse Laplace of 1 over s plus 3 equals to e to the minus 3x. and inverse Laplace of 4 factorial over s to the 5 equals to x to the 4. From the second elementary condition here, which is Laplace of e to the ax equals to 1 over s minus a, constant a is minus 3 here. 4 factorial over s to the 5 is actually 4 factorial over s to the 4 plus 1. If I apply the first elementary condition here, which is Laplace of x to the n equals to n factorial over s to the n plus 1, the value of n is 4 here. That's how I got 4 factorial over s to the 5. So this is my final answer. Inverse Laplace of 4 factorial over s plus 3 to the 5 equals to e to the minus 3x times x to the 4. But if you want to prove that whether my answer is correct or not, let me take their Laplace. So I will go back. Laplace of e to the minus 3x equals to 1 over s plus 3. And Laplace of x to the 4 equals to 4 factorial over s to the 5. Put s plus 3 in s to get 4 factorial over s plus 3 to the 5. Therefore, my answer e to the minus 3x times x to the 4 is correct here. Example. Solve inverse Laplace of 2 over s minus 5 to the 2 plus 4. Again, if you look to the function f of x, it is the product of two subfunctions. One is 1 over s minus 5 and the other is 2 over s squared plus 4. So let me find the inverse Laplace here. Solution. One function is 1 over s minus 5 and the other function is 2 over s squared plus 4. I'm gonna take 1 over s minus 5 out of the function to have inverse Laplace of 1 over s minus 5. And now I left with 2 over s squared plus 4, which is my second subfunction, 2 over s squared plus 4. So the given function f of x is the combination of these two subfunctions. Let me write inverse Laplace of 1 over s minus 5 times inverse Laplace of 2 over s squared plus 2 squared. Inverse Laplace of 1 over s minus 5 equals to e to the 5x. Inverse Laplace of 2 over s squared plus 2 squared equals to. How to know that? According to the second elementary condition here, which is Laplace of e to the ax equals to 1 over s minus a, my constant a is 5 here. It is according to the fourth elementary condition. My constant a is 2 here. So this is my final answer. Let me prove that the answer e to the minus 5x times cos 2x is correct. I will take their Laplace. So I will go back. Laplace of e to the 5x equals to 1 over s minus 5, 2 over s squared plus 2 squared. Put s minus 5 in s to get 2 over s minus 5 to the 2 plus 4. Hence my final answer e to the 5x times cos 2x is correct. Example. Solve inverse Laplace of 3 factorial over s minus 2 to the 4. When you look to this equation, it is different compared to the previous examples. My function f of x is the product of two functions. So let me find the inverse Laplace here. Solution. If you see here, 1 over s minus 2 is one function, and 3 factorial over s to the 4 is another function. Take 1 over s minus 2 outside of this function to get inverse Laplace of 1 over s minus 2. And I left with s to the 4, which is 3 factorial over s to the 4. This is another function, 3 factorial over s to the 4. Just separate these two functions from each other. Let me write inverse Laplace of 1 over s minus 2 times inverse Laplace of 3 factorial over s to the 4. Inverse Laplace of 1 over s minus 2 equals to e to the 2x. And inverse Laplace of 3 factorial over s to the 4 equals to x to the 3. If I apply the second elementary condition here, which is Laplace of e to the ax equals to 1 over s minus a, the value of constant a is 2 here. 3 factorial over s to the 4 is actually 3 factorial over s to the 3 plus 1. If I apply the first elementary condition here, which is Laplace of x to the n equals to n factorial over s to the n plus 1, where n is 3 here. So that's how I got 3 factorial over s to the 4. This is my final answer. So the inverse Laplace of 3 over s minus 2 to the 4 equals to e to the 2x times x to the 3. What I did here, I changed the given function, which was the combination of two different subfunctions, from s domain to exponential function and algebraic function. That's what we do in inverse Laplace, to change the equation from s domain to another form. But if you want to prove that e to the 2x times x to the 3 is correct, let's take their Laplace. So I will go back to the top. Laplace of e to the 2x equals to 1 over s minus 2. And Laplace of x to the 3 equals to 3 factorial over s to the 4. Now if I take s minus 2 and put it here for s, just replace s by s minus 2 here to get this value 3 factorial over s minus 2 to the 4. I just put s minus 2 for the s to get back 3 factorial over s minus 2 to the 4. So you see here that inverse Laplace is totally opposite to the Laplace process. Example. Evaluate inverse Laplace of s over a square minus 8s minus 9. Look to this question. It is completely different compared to what we saw in previous examples. What we're going to do here, we're going to use partial fraction process here. Solution. Let me solve s over a square minus 8s minus 9 by partial fraction process, which equals to a over s minus 9 plus b over s plus 1. I just apply the partial fraction process. Now I'm going to find the values of a and b. Let me take the LCM here to get a times s plus 1 plus b times s minus 9 or s minus 9 times s plus 1. The value at denominator at both sides will cancel each other. So I left only with s equals to a times s plus 1 plus b times s minus 9. If I put the value of s equals to minus 1, just put the value of s equals to minus 1. I will get the value of b equals to 1 over 10. Well, this is my b. But if I put the value of s equals to plus 9, just put the value of s equals to plus 9 and simplify the equation, you will get the value of a equals to 9 over 10. These are the values of a and b. Let me put the values of a and b here to have 9 over 10 over s minus 9 plus 1 over 10 over s plus 1. This is my a and this is my b. Can I write 9 over 10 times inverse Laplace of 1 over s minus 9 plus 1 over 10 times inverse Laplace of 1 over s plus 1. Just take 9 over 10 and 1 over 10 outside. The inverse Laplace of 1 over s minus 9 and 1 over s plus 1 equals to e to the 9x and e to the minus x. According to the second elementary condition, which is Laplace of e to the ax equals to 1 over s minus a. Constant a is 9 and minus 1. For the left term, constant a is plus 9. And for the right term, constant a is minus 1. This is my final answer. So the inverse Laplace of s over a square minus 8s minus 9 equals to 9 over 10 times e to the 9x plus 1 over 10 times e to the minus x.